Good evening. Today we are going to start our continuation lecture on rational numbers. We have dealt with the introduction of rational numbers and different number systems. Today we will be dealing with the properties of rational numbers. The first property is closure property. What the closure property says? Closure property means if we add, subtract, multiply or divide two numbers of the same system, then we get a number of the same system. Let me explain with the examples. We will be taking it for whole numbers, integers and the rational numbers. Suppose we take whole numbers a and b. A is 1, b is 3. We go with the addition a plus b, that is 1 plus 3, we get 4. So this 4 is a whole number. That means 1 and 3 are whole numbers and 4 is also a whole number. So whole numbers are closed under addition. Second, we take subtraction a minus b, 1 minus 3 which is equal to minus 2, which is not a whole number. So we can say whole numbers are not closed under subtraction. Again we take multiplication, a multiplied by b, a into b, that is equal to 3, which is also a whole number. So we can say whole numbers are closed under multiplication. Again we go with division, a divided by b is equal to 1 by 3 is equal to, this is not a whole number. So we can say whole numbers are not closed under division. Now we go with the integers, we take two integers a and b. A is 1 and b is minus 3. Now we add them, a plus b, that means 1 plus minus 3, which comes out to be minus 2. Now we can say minus 2 is also an integer. So we can say integers are closed under addition. Now we take subtraction of the two numbers, 1 minus of minus 3, that means 1 plus 3 is equal to 4, which is again an integer. So we can say integers are closed under subtraction. Now we go with the multiplication of the two numbers, 1 multiplied by minus 3 and we get minus 3, which is again an integer. So we can say that the integers are closed under multiplication also. We go with the division, 1 divided by minus 3, which is not an integer. So we can say that the integers are not closed under division. Now we move to rational numbers. We take two rational numbers a by b and c by d as 1 by 3 and 4 by 3. We add both of them. 1 by 3 plus 4 by 3, it comes out as 5 by 3, which is also a rational number. So we can say rational numbers are closed under addition. Now we go with the subtraction, a by b, 1 by 3 minus 4 by 3 is equal to 1 minus 4 is equal to minus 3 upon 3, which comes as minus 1, and which is again a rational number. So we can say that the rational numbers are closed under subtraction also. Now we move to multiplication. A multiplied by a by b multiplied by c by d, that is 1 by 3 multiplied by 4 by 3, then it comes as 4 by 9, which is again a rational number. So we can say that the rational numbers are closed under multiplication also. We go with the division. 1 by 3 divided by 4 by 3, which comes as 1 by 3 into 3 by 4 as 1 by 4, which is also a rational number. But we have to take a condition, as 0 is a rational number. 0 is a rational number and return as 0 by 1. Reciprocal of 0 by 1 is equal to 1 by 0, which is equal to infinity. So if we take a number c by d as 0, then 1 by 3 divided by 0 by 1 then it comes as 1 by 3 multiplied by 1 upon 0, that is equal to 1 by 3 multiplied by infinity, which is not a rational number. So we can see that the rational number are not closed under division. To sum up the whole thing, we can say that the whole numbers are closed under addition and multiplication, but not under subtraction and division. The integers are closed under addition, subtraction and multiplication, but not under division. Same way, rational numbers are closed under addition, subtraction, multiplication, but not under division. So we have completed the closure property. Now from